Okay, I see what I was talking about. It's not continuous with all this. It's in response to a question I got after class. The question was from a student, and a very good student, why would the maximum rate of change not be whichever of these slopes is the greater? Because the maximum rate of change, again, could also be expressed as a slope if you move in this direction. So I could expand the picture. I could draw this rectangle, and I could see that if I move from here to here, if the linear approximation is, to the extent the linear approximation is valid, I'm going to have a change. Well, I can draw a line segment here that's parallel to this one, and I'm going to get a del z hat here, same as this one. And then I can sketch a segment over to here, and then I've got to put a segment like this on top of it, and so forth. Hoping I can draw this and make sense out of it, so that as I move from here to here, I complete this right triangle that I'll shade in different color, where the rise is delta z hat plus delta z tilde. Delta z hat for the movement in this direction, delta z tilde for the movement in this direction. The run is 1. So the slope up here where I don't really have room slope of this triangle is delta z hat plus delta z tilde, the change in z, divided by the run, which is the same as this distance here. This is 1. And that one doesn't look all that much like a 1. Okay, and that's equal to what? Fx delta x plus Fy delta y. So this slope, and I don't want to try to label it in here, you can complete the figure for yourself if you want. The slope, again, of this segment here that runs from here to this point, which could be arrived at by going from here to here and up to here, where, let's emphasize, this is a right angle. Slope is Fx delta x plus Fy delta y. And that equals Fx cosine theta plus Fy sine theta. That equals the directional derivative, which is the rate of change of F with respect to distance because the distance is 1. There's our change, there's our slope. Okay. Hopefully that's somewhat clarifying. You know, we'll be addressing it more in the future. Now, what I got down here, the question I got is, again, why would the maximum rate of change not be the greater of these two? Well, it's because let's just say that the rate of change in the y direction is greater. The rate of change in the x direction, though, is positive. Okay, so we'd have the rate of change in this direction. Now, if we move this direction a little bit toward the x direction, what happens? Our delta y gets a little smaller, our delta x gets a little bigger. Okay, and that's what I'm depicting here. So here's our y direction, let's say, and here's our x direction. And the rate of change in the y direction is, let's say, 5. The rate of change in the x direction is, let's say, 3. Now, if I move from this direction, assuming that I'm using a distance of 1, remembering how I explained this, if I move a distance of 1 in this direction, then my y is going to change by, well, if the rate is 5, it's going to change by 5. If I move a unit in this direction, where the rate is 3, then the change is only going to be 3. So this change is going to be bigger than this change. Now, if I take this direction, though, and change it by just a little bit, I don't shorten the y component by very much, because the y component and the hypotenuse are going to remain very, very close until x gets pretty big. Okay, so I can make a significant change in x without making any significant change in my delta x, where delta x would be the change in this direction, without significantly changing my delta y. So this was clear to the student when I explained it. But so my delta y is from here to here. My delta x, let's say, is from here to here. Okay. I can change my direction a little bit and get a significant change in delta x without a significant change in delta y. So I'm going to get more change if I go along this path than if I go along this path. My change along this path would be 5. My change along this path for the y direction is still going to be very close to 5, but I'm going to get a significant change in x, and therefore the change in this direction will be greater than the change in this direction. Now I could do that in more mathematical terms with symbols and prove it algebraically, but that's not particularly intuitive, and I'm trying to stay intuitive with this. So again, that's not going to be my maximum. That's not going to be the direction for my maximum rate of change. Because again, by moving just a little bit this way, I still have almost the same delta y, but I've got still almost got the same change in z due to my delta y, because I've got almost the same delta y, but I've got a much bigger delta x. So I'm adding more by moving in this direction. I'm adding more because of my delta x than I'm losing for my delta y. And you should set that up algebraically and see if you can prove it.